Hi, I'm Joan Cartan-Hansen, and welcome to Science Trek, the web show, and welcome to the College of Idaho's Physics Lab. And answering your questions today about states of matter are Kathryn, Devine, and Christopher Saunders. Thank you for being here.
Thank you, Joan. It's really nice to be here.
Yeah, thank you for having us.
Okay, let's go to your questions.
Hi, my name is Gabriel, and I'm from Cynthia Mann Elementary, and my question is there any gas that fish breathe?
Absolutely, yeah. So if you have a fish tank at home, you might notice that you have a filter that oxygenates the water, or it kind of splashes around, and some people have bubblers in their fish tank. And that's because fish, just like us, breathe oxygen. They need oxygen in their blood to live. So in water, there needs to be a certain level of oxygen gas kind of mixed into the water for the fish to be able to breathe. There's other stuff in there besides oxygen, but oxygen is the one that helps them stay alive.
So in how they get that oxygen, so their gills serve as a membrane that the dissolved oxygen in the water can pass through the membrane. We call that diffusion. So it can diffuse through that membrane and into their bloodstream. Just like when you take a big gulp of air, that oxygen in the air can diffuse through the tissue in your lungs and get into your bloodstream.
Hi, my name is Rook. I come from Cynthia Mann Elementary. My question is there anything different in space air?
Yes, so there's a lot of things different in space air is the short answer. One of the biggest differences between kind of the air in outer space and air here on Earth is how dense it is. So kind of in general space, outer space, air is so low density that you can have in a cubic centimeter just a single hydrogen atom per cubic centimeter, which is tremendously lower density than the air we breathe down on here on Earth. And then the other thing that's very different is the composition of the gas in space. And so here on Earth, we have things in our oxygen like carbon dioxide, we've got nitrogen, we've got oxygen, we've got water vapor. And a lot of those different compounds exist out in space, but they're much more rare. In space, most of the gas is just hydrogen and not a lot else, but there are trace amounts of these other things. So what we take for granted here on Earth is actually very rare to have this nice thick atmosphere of dense gas that we can breathe.
And I think it's important to note that most people think of space as being empty, of being devoid of matter, and it really isn't, right? There's not as much stuff as we have here on Earth, but there's still matter within space.
Hi, my name is Adrian from Cynthia Mann Elementary School, and my question is, how does water fluff into clouds?
So what you're actually seeing when you look at a cloud, it's pretty interesting actually. So you have gas or water in its gas form out in the atmosphere. And when a cloud forms, there's dust in the air and the water condenses. And so condensing means that there's a phase change of matter from its gas state back to its liquid state. And so condensation occurs around those dust grains and you get water, tiny, tiny, tiny droplets of liquid water up in the atmosphere. And that's what we see as clouds, because when water is in its gas state, it's invisible. And so if you're able to see it, then that means that it's condensed back into its liquid state.
And it's important to think about as well that not all clouds, they're not necessarily pure water. So certain chemicals that we put out into the air, so different pollutants, can also be part of those clouds. So it may not just be liquid water that's up there. And some of those chemicals are then what we produce, what we call acid rain.
Sam asks, do gases float around forever?
Well, forever is a really long time. But what I can say is that, so some gases, sure, if in their natural state, so let's say oxygen, for example. So oxygen gas, it's in the air that you're breathing right now. In its natural state, so normal pressure and temperature that we find in this room, it's going to exist as its gaseous state. Is it going to stay as a gas forever? Not necessarily. At some point, maybe a scientist collects that oxygen and decides to compress it down and get it really cold, and it might turn into liquid oxygen that can be used to fuel rockets that take a ship to space. So again, the answer is some of it maybe, but a lot of, again, we cannot create or destroy matter. So just because it's a gas doesn't mean it's always going to exist as a gas.
But what I'm hearing you say, Chris, is that if it as long as nothing changes its temperature, its pressure too dramatically, it will stay a gas unless something acts on it to change it to a different form.
Correct. So for a phase change to happen, something has to change in its environment to change its phase. So yeah, so if we have a substance that exists as a gas and we don't change the pressure and we don't change the temperature, then sure, forever it would stay as a gas.
Hi, my name is Jaron, and I go to Cynthia Mann Elementary School, and my question is, how many gases do we breathe in at once?
Well, that would depend on where you're at that point in time. I can tell you most of what you're breathing is nitrogen, so most of the air that we breathe in is nitrogen. Hopefully there's oxygen in the air that you're breathing, otherwise you'd find it difficult to breathe. But those two things make up the bulk of the air that we breathe. We can add in carbon dioxide, small amounts of a gas called argon, and other trace gases that might exist, again, in different concentrations depending on where you're at any given point in time.
Hi, my name is Zephyr, and I'm from Cynthia Mann Elementary, and my question is, how is Jupiter made of gas?
So Jupiter is one of the planets in our solar system known as the gas giants. There's 4 of them. We've got Jupiter, Saturn, Uranus, and Neptune. And all of those planets formed much further away from Earth, or from the sun than Earth did. And so we think that the distance had something to do with how the planets formed and the fact that they became gas giants. But one of the things that people may not realize is that Jupiter is probably not all gas. It has a very thick, massive gas atmosphere, but most astronomers believe that at the core there's either a solid or possibly a heavy liquid, a very dense liquid core in the center of Jupiter.
Katie would like to know, why is matter important?
Why is matter important? Well, think about where we would be without matter. We wouldn't be without matter. We're made of matter, and so all of the liquid you drink, all of the stuff you're made out of, that's matter. And so I think matter is pretty important to me just because I like to exist, and I like to be made of matter.
Well, and if there was no matter, then I wouldn't have a job. So the study of matter is what we call chemistry. And I like to tell my students oftentimes that chemistry is the study of the familiar, because matter is all around you. You're made of matter, right? You're touching matter all the time. You can't get away from it. So if you're right, if anything is important to you, then matter is important because it's made out of matter.
I'm sorry, we've run out of time. My thanks to Chris and Kathryn for answering students' questions today.
Thank you, Joan. It was nice to be here.
Thank you for having us.
And thanks to the folks here at the College of Idaho for hosting us. If you want to learn more about this topic, check out the States of Matter area on the Science Trek website. You'll find facts, links, games, our States of Matter broadcast show, and lots more. And every week, check out my blog for the latest science news for kids, all at idahoptv.org. Thanks for joining us, and we'll see you next time here on Science Trek, the Web Show.